Okay, we are here graphing quadratic equations. We're given the equation g of x equals negative 2x squared minus 6x minus 4. I can really think of this as, from a graphing perspective, y equals the function g, which is a function of x, and here is my quadratic equation. All right, the first thing I'm going to do is put my function into factored form. I'm given it in standard form, but it'll be easier if I put it into factored form. So I'm going to do that first by finding a GCF first. My GCF is equal to negative 2. Factoring that out will give me, and I'll use the letter y, negative 2 times x squared plus 3x plus 2. Now I want to factor this simpler quadratic. So I'll use our box method. I can see that a equals 1, b equals 3, and c equals 2. So drawing in my box, I place the x squared term in the upper left and my constant term in the lower right. I form my big X. I want a pair of numbers that multiply to be AC and add to be B. Well, AC in this case is 1 times 2 or 2, and B is, in this case, 3. So my very first pair, 1 times 2, does indeed add to 3. So that is the pair that works for me. And I'm going to place those numbers in my box, appending the X as a factor. So looking at my box now, in the first row, what goes into both x squared and 2x is x. In the second row, what goes into both 1x and 2 is a positive 1. Looking at my columns, if I pull an x out of x squared, I'll be left with x. And if I pull an x out of 2x, I'll be left with a plus 2. Thus, my factored form now looks like y equals negative 2, my GCF, times my factorization, x plus 1 times x plus 2. I can write this in my answer area as y equals negative 2 x plus 1 times x plus 2. Now that I have it in factored form, what I can do is I can find the second thing, my x-intercepts. X-intercepts are where my function intersects the x-axis. Now everywhere along the x-axis, y equals 0. So what I'm doing is I'm going to set y equals to 0 and solve for x. That's how I get my x-intercepts. So what is y? Y is negative 2 times x plus 1 times x plus 2, and I will set that equal to 0. Well, if this product equals 0, then one of these factors has to equal 0. Negative 2 can never equal 0, but I can have either x plus 1 equals 0 or x plus 2 equals 0. And I can solve each of these for x. I can subtract 1 from both sides for this case, and I'll have x equals negative 1. And for the other case, I can subtract 2 from both sides, and I'll be left with x equals negative 2. Those are the points where I will intersect the x-axis, and we write them as an ordered pair since they are points with an x value and a y value. So negative 1, 0 is my 1 point, and negative 2, 0 is my second point. And I'm going to write that in my answer area, negative 1, 0, and negative 2, 0. I'm going to plot it on my graph. Here's x equals negative 1 and y is 0. And here, right next door, is x equals negative 2 and y equals 0. Moving on, having these x-intercepts makes finding the axis of symmetry fairly straightforward, because the axis of symmetry bisects or divides in half my graph. It's going to go right in between those x-intercepts. And I can think of that from a mathematical point of view as being the average of the x-intercepts. So my axis of symmetry is an equation, x equals the average of these x values, -1 and -2. Averaging them means adding and dividing by 2. So I have -3/2, or in decimal form, -1.5. I can write that in my answer areas, x equals -1.5. Now that I have my axis of symmetry, I look for the vertex. The vertex is that point that's right in the middle of my graph. So it's always going to lie on the axis of symmetry. And if I know that, that means I know the x value, it's -1.5. So to get the vertex, I'm just going to plug x equals -1.5 into my equation. So I can use either the original equation in standard form, or I can use my factored equation. So I think I'll use the factored form in this case, and I'll plug that in. So I'll write that over here. Y equals -2 times x plus 1, but in my case, x is -1.5 plus 1, and then times x plus 2, that's -1.5 plus 2. So I have -2 times -0.5 times positive 0.5. Okay, and that's going to give me a value of 0.5 times 0.5 is 0.25 times 2 is 0.50. That's going to be a positive 0.5. So that's my y value. So my vertex is going to be my x and my y. -1.5, 0.5. And I can write that in my answer area. -1.5 and 0.5. And I'll put that on my graph. It's all bunched together here. But there it is. Oops. Let's undo that. Because it is a positive value. So it's actually going to be up on top. Okay? There. Now, corrected my mistake. And I've got these 3 points right here. And my axis of symmetry. All right. Now, I'd like to get another point in here, and the y-intercept is a fun one to get. So that's going to be the fifth thing that I get, my y-intercept. And the y-intercept means that every place along my y-axis, x is 0. So I can simply plug 0 into any form of my equation and find out what the y value is. So I'm going to do that. And I'll use my original form of the equation. That's in g of x equals -2x squared minus 6x minus 4. So if I plug a 0 in there, I have -2 times 0 squared minus 6 times 0 minus 4. And that simply equals -4. So you might have noticed that that is actually the c value of my original equation. So it's 0, -4. And I'll plot that, 1, 2, 3, 4. It's right here. I can write that in my answer area as 0, -4. And to help my graphing, I can even use the symmetry property to know that if I've got a spot at 0, -4, looking over my graph, I'm going to have another spot over here at -3, -4. I have enough points now that I can actually draw my graph. It's going to look like this. And coming down like that. All right, so this leaves me lastly looking at my maximum or minimum value. You can see from the graph that I have a maximum value. The graph never goes above x equals 0.5. So I have a maximum value. And that maximum value is the same y value I had for my vertex. So that is 0.5. The last remark I'll make is that we can also find that the max value comes from the original equation. I know that I had a negative 2x squared. So that told me that my original equation, a equals negative 2, so that meant that my shape was opening downward. And that tells me that I have a maximum. Okay? And there you have it. Graphing quadratic equations, finding the factored form, x-intercepts, axis of symmetry, vertex, y-intercept, whether or not it is a max or a min, and what that value of the max or min is.